Everyone, this video is on mixed exercise 14 challenge question. So in part A, we are given that y is equal to 9 to the power of x, and we want to show that log base 3 of y is equal to 2x. Right. So the first thing that we can do is just rewriting 9 as 3 squared, but since we have x in the power, this becomes 3 to the power of 2x. So that's the first thing. Now, for the next step, we can simply take log of both sides with base 3, right? So we do log base 3 of y is equal to log base 3 of 3 to the power of 2x. Now, the left-hand side is still log base 3 of y. However, the right-hand side, we have log base 3 of 3 to the power of something. But remember that whenever the base and the number inside the log are the same, this is just equal to 1, right? Because we were saying that 3 to power of what number is going to be equal to 3. So that's equal to 1. So we just simply then get 2x, right? And that's exactly what we wanted to prove. So that's the end of the proof here. Now, in part B, we want to deduce that log base 3 of y is equal to log base 9 of y squared. Right. So we know that y is equal to 9 to the power of x. Now, when we take log base 9 of both sides, because we need to have that. So let's see what happens. So we get log base 9 of y is equal to log base 9 of 9x. And now we just need to simplify the right hand side. So when we simplify the right hand side, because the left hand side remains the same, so it's just log base 9 of y, but the right hand side, log base 9 of 9 is just equal to 1, so we just get x, and it's very important. So x is equal to log base 9 of y. Now here we can use a very interesting trick that we can multiply both sides by 2, because if we do so, we'll get 2 log base 9 of y is equal to 2x. And notice that from part A, we have log base 3 of y is equal to 2x. So we can now substitute that into 2x. So we'll get log base 3 of y is equal to 2 log base 9 of y. And now we can just use the power law of logs. Whenever we have a coefficient outside of the log, this can be written as the power of whatever is inside the log. So we'll have log base 3 of y is equal to log base 9 of y squared. And this is the end of the proof in the second part. So in part C, we just want to use the answer to part B to solve the equation that is given to us. Right, so we have this equation, and one of the first things is that because we want to use the answer from part B, so in part B, we basically got that log base 3 of y is the same as log base 9 of y squared. So that simply means that we can basically write log base 3 of 2 minus 3x equal to log base 9 of 2 minus 3x squared, right? Because that's exactly the result that we derived in the previous part. So we're going to square this term inside here expression as long as the base changes from 3 to 9. And that's exactly what happened here. So we deduce that the base changes to 9, and then this expression is going to be squared. And now the whole point of doing this was to rewrite the left-hand side as a log of base 9. So the left-hand side becomes log base 9 of 2 minus 3x squared, because this way we can simply solve the equation. Is equal to, now the right-hand side doesn't change. We haven't done anything to the right-hand side. Log base 9 of 6x squared minus 19x plus 2. And this is the good part, because we now have log base 9 in both sides, so we can just simply solve this as a simple quadratic, like the same as when we have equation like 2 to the power of x is equal to 2 to the power of, let's say, 21. So in this case, we can just say x is equal to 21. So, or maybe something more interesting, 21 plus 3x. So we can set this equal to x is equal to 21 plus 3x. So this is the same technique. Now we have 2 minus 3x squared is equal to 6x squared minus 19x plus 2. So we have 4 minus 12x plus 9x squared is equal to 6x squared minus 19x plus 2. And now we just rearrange this. It becomes 3x squared plus 7x plus 2 is equal to 0. And we can factorize this. So 3x plus 1 times x plus 2 is equal to 0. And the solutions are minus 3 or minus 2 for the value of x. And both of these values are allowed here because when we substitute them into the original equation, they don't make the inside part of the log negative. So that's fine.